Right, so we're going to finish off section 2.4 with a couple more examples of equality of sets. So we're going to do one where we're working with two sets. The only difference between this example and the previous one we were specifically looking at De Morgan's laws. So we're going to look at just kind of some different examples in this last page, and then we'll do one using two sets that we see up at the top here, and then one that's a little bit more involved that has three sets down at the bottom. All right, so determine whether A union B complement is equal to A complement union B complement. All right, so to start with, again, our tables are kind of laid out for us here. A union B are regions 1, 2, and 3. And our complement of that, anything outside of our circles, well, that's region 4. All right, A complement outside of A, again, is set 3 and 4. B complement, remember, is our region 1 and 4. They're outside of B. And A complement union B complement. Union means we want anything and everything. Right, so we have 1, 3, and 4. If we compare our last lines here, these are clearly not the same thing. So these are not equal. So is this true for all sets A and B? No, it is not. Right, so let's do one more example doing the equality of three sets. So we're going to determine whether A union, and then we have the intersection of B and C, is equal to A union B intersect A union C. So again, what we're looking at here, we have a Venn diagram that has three sets. So we're going to go through when we're doing these. Remember that we have these 8 regions, and that's what we're going to be comparing. All right, so we start by listing every region in set A. So we have 1, 2, 4, and 5. Right, and then we are asked to identify B intersect C. So B and C, well, these overlap in regions 5 and 6. Then we are asked to union, right, these two parts that we have here. So we're going to have everything that we have listed here. So 1, 2, 4, 5, which is in both, and then 6, which is just in our second line. All right, now we're going to go through and fill in our table on the other side. A union B. So we want anything that's an A or B. So that's going to be 1, 2, 3, 4, 5, 6. Right, A union C. 1, 2, 4, 5, 6, 7. Right, and now we want the intersection of these two regions, lists of regions that we have here. So we want only the ones that appear in both. Right, so 1 appears in both, 2 appears in both, 3 does not, but 4 does, 5 does, and 6 does. Right. And if we compare these, right, these guys are equal. So we can go back up and answer our original question. Determine whether this is true for all sets A, B, and C. Yes, it is true. So equality of sets, you want to kind of start with a picture, look at your regions, try to identify what is in each region that we're looking for, and then determine are those regions that we're comparing for our different things the same, right? Are they equal?